Mac there. I hope you enjoyed that. Hey, we did some multiplication of radicals and some simplifying of radicals. We've taken care of that part. We just got to do one more thing here with them, and then we're going to do some addition and subtraction. I don't know if we'll get to all that, but we'll see what happens. Quizzes. Hey, if you know what, I don't know what more I can say, but I did so a couple of other classes put their quizzes in their shared folder, and that worked out real well. You can upload them to your Google Drive and share that folder with me, and that worked out well. I was able to view them without any problems. So you might want to try that. The thing that would be helpful is if on your shared folder, you titled, I told you to call it math or whatever, that's okay, except I can't tell whose is whose. So if you could put math and maybe just put your name there, your first name or something, and that way I know whose folder it is. Otherwise, I got to go through all these folders and figure out who's who. So that would help me out a bunch. Okay, let's get after this thing here. Let's see. I'm thinking, let's go with some little blue action right here. All right, and we're going to talk about rationalizing square roots. Okay. There's somebody sharing something with me right there, huh? We'll fix that for you guys. Sorry about that. All right, so we're going to rationalize some radicals, and basically it is how you're going to divide. And really haven't done it. We did a tiny bit of this when we did complex numbers, but not a lot. So first of all, let's go ahead and pick a couple of them, and maybe we'll do a couple addition and subtraction, then we can kind of wrap that up. So let's say that we have a 3 over the square root of 5. So that is supposed to be a 3. There we go. We cannot have a square root in the bottom of a fraction. That's one of those mathematical laws that you can't have one there. So to get rid of that, we simply just multiply it by the square root of 5, top and bottom. And we can do that because that's just 1. So when you do that, you get 3 square roots of 5. Remember, you always multiply. You can't multiply the 3 and the 5 because the 3 is on the outside, doesn't have a square root. So it just multiplies, goes to the front basically. When we multiply these, we can do that. That's the square root of 25. But in reality, that's just 5. Right? And that's all you can do there. That's called rationalizing. And I know you're really tempted to do this, but that would be a bad thing to do. So don't do that. So the answer here is 3 square roots of 5 over 5. All right, so let's try another one here. This is rationalizing. Let's go with a 4 over the square root of 8. Now, you can simplify right away, but I kind of like to do it afterwards. I don't know why. I think it's just a tad bit easier, but you can. So let's do this. So I'm going to go 4 square roots of 8 over, and I know that the square root of 8 times the square root of 8 is the square root of 64, but that turns out to be 8. So in this case, all right, you go ahead now, and we can do some simplifying, and we can do some canceling out. But let's go ahead and let's simplify this thing. All right, so I'm going to go. Remember, to simplify that, I got to find the largest perfect square that goes evenly into 8. So I list out those perfect squares that I had before. I know the first one was 1, and I had 4, then I had 9, and I had 16. Well, obviously 8 can be broken down to 4 and 2. So the square root of 4 is 2. That 2 is going to pop out in front of that and multiply with it. So now that can be simplified to there. And now we can cancel. So there's our answer right there. So we took the square root of 8, right? Broke that down to 4 times 2. Took the square root of 4. That's 2. That 2 comes out, multiplies to this 4, and gives us 8. And then the 8's cancel. So let's do another one. again, this is called rationalizing the denominator. And it's basically a division, but we're rationalizing. Okay, now we have one like this. Now in this case, you could do a couple different things. One, you can rationalize, or you can write it like this. And that is okay to do that. Now, why do we do that? Well, because now I can reduce what's inside there, and I get this, which is this thing. So now that's considerably easier to rationalize. So then I would multiply by the square root of 3 over 3, and I get the square root of 3. 3 times 3 is 9, but the square root of that gives me 3, and there's the answer. So instead of just straight up multiplying by a square root of 15, because these are both square roots, I can write it as 1, reduce the fraction, and then do the rationalization. Now, if reducing the fraction doesn't do you any good, then just go ahead and rationalize it. All right, so you can do that a couple different ways. Let's continue with this a little bit. What if we have something like this? So we have 2 plus the square root of 5 on the bottom. All right, so this was a little bit like what we did with the complex numbers, but just a tiny bit. We're going to multiply the top and the bottom by what we call the conjugate. And the conjugate of a number written in that kind of square root form. So if it's a minus the square root of b, the conjugate is just going to be a plus the square root of b. It's all it does is change that sign. So instead of going with the square root of 5, which we can't do, we have to incorporate the whole thing. So see how I change this plus, all right, to a minus. So now I can go ahead and simplify this. So let's do the top first. So I'm going to get 2 times 3, that's 6, and 3 times that square root of 5 is going to be 3 square root of 5 again. I cannot multiply 3 times 5 because 5 is underneath the square root. 3 is not underneath the square root, so it has to be left alone. Now on the bottom here, we're just going to FOIL this, and we did some foiling a little bit ago. So that was 4, and we're going to go minus 2 square roots of 5. Gosh. All right, 2 minus the square root of 5 plus 2 times the square root of 5. Again, we cannot multiply the 2 and the 5s. 5 is underneath the square root, the 2 is not. In this case, though, we can do the square root of 5 times the square root of 5, which is the square root of 25, but that just changes into 5. So here we have this little mess going on down here, but it's really not as bad as it seems. First of all, the top is done. I can't really do anything to it, so I'm going to leave it alone for right now. All right, and I'm going to work on the bottom. Notice what happens to these. That's a good thing. They cancel out, and that's why you multiply by the conjugate, is the whole idea is to get rid of that. I have 4 minus 5, which is just negative 1. So what I'm going to do is just kind of simplify this a little bit here. I'm going to change that to a negative 6. I'm going to change this to a plus 3 square roots of 5, and that's done. Right there. So recapping this a little bit, we multiply by something called the conjugate. That's what that is. It changes this sign. So if it's negative, change it to positive. If it's positive, change it to negative. Reason being is that this middle stuff here is going to cancel out when you do that, so it gets rid of the radicals. One more like that. So let's say we have 2, okay, 1. This time let's go with minus square root of 3. So here, again, we're going to multiply the top and the bottom by the conjugate. So that's going to change that sign to this. So we have that. And now I'm going to multiply. So on the top, this 2 is going to go to both of these things here. There we go. And now I'm going to go ahead and do the bottom. So 1, so I'm going to FOIL. I know I'm going to get a plus square root of 3, and I'm going to get a minus square root of 3. Those things are always going to cancel. And then I'm going to get a minus square root of 3 times the square root of 3. By now you're figuring out that that's going to be 3. So the top is already done. I can't do anything with that right now. Square root of 3's are going to cancel out because one's plus, one's minus. I get a negative 2. 1 minus 3 is a negative 2. And the good news is that these can go away. So 2 divided by negative 2 is negative 1. 2 divided by negative 2 is negative 1. And there's my answer. So the 2 has to go into both of those things in order to make that work. It can't just go into one. It's got to go into both. All right. Let's see. So just for the heck of it, I want to show you a little bit of addition here because doing the addition ones is pretty simple. If we have something like this, the square root of 5, and we want to multiply, or excuse me, we want to add these up. So I'm going to put like a little parentheses with a big plus there. 4 plus the square root. Let's go like this. Let's erase that. Let's go with 3 square roots of 5. Then what I want to do is I want to add the like terms. So I can add this one and this one. And I can add up this one and this one. Okay, that's the only thing you can do there. You can only add the like ones. So here I have 2 and 4, so that gives me 6. Here I have plus 1 square root of 5 plus 3 square roots of 5 gives me 4 square roots of 5. Not 10, it's 5s. So it's very much like a fraction. So if you had like 1/5 plus 3/5, you get 4/5. They got to have common numbers underneath the radicals to add them. You cannot add these unless they have common numbers underneath them. So if we have 8 minus the square root of 7 plus 2 square roots of 7 minus 10. So here we can do these numbers, obviously. That's going to be a negative 2. And here we can only, since they both have a 7 underneath there, we can add those up. So we have a negative 1 square root of 7 plus 2 square roots of 7 gives us 1 square root of 7. And that's it. That's how you add and subtract them. It's pretty straightforward, not bad stuff. You'll see them something like this. And then they'll put a minus out in front. And something like this, maybe. Actually, let's change this around a little bit. Oops. I got a better idea. Let's make this a 98. And let's make this a 32. Okay, so in this case, you go, well, we can't do anything with those because they're not like. Well, you can simplify them though. So if we go 3 plus, we got to find the largest perfect square that we can break that down into. So I'm going to go right down the line. So I got 4. Let's see, 4 might go in there, but 98 is a pretty large number. Let's see if we can do better than that. So 4, let's try 16, 9, 36, 25, 49. Ooh, 49. 49 is the largest one for sure. So 49 goes in there twice. Square root of 49 is 7, so that 7 comes on the outside. Now we have that. Minus. Minus 2. Minus. Now let's break this one down. Again, we want to find the largest perfect square. Yep, 4 and 8 works. I know that. But we should try and see if there's more. I think 9 doesn't work. 25 or 16 though. 16 does. 16 goes in there 2 times. So that would be 4. Man, oh man. 4 square roots of 2. Now, they do combine up. See, because they're both the same underneath there. Alright? So here we go. So we can go 3 minus 2. So that's 1. Now I have 7 square roots of 2. This minus is going to come in here and make that a plus. Plus 4 square roots of 2 is going to give us 11 square roots of 2. So I think what I'm going to do is have you do some rationalizing. We'll do some adding and subtracting. Not make it too much for you, but we'll just kind of get hit and miss a few things so that you kind of know what those are. Documents, questions documents, put your questions in there. That's what you're going to see, hopefully. The more questions you get, the more I will show that video on Friday. I'm not sure you know about the furlough thing. It's kind of up in the air a little bit. But if that kind of goes all the way through for myself, it might and it might not. Then I can't answer any emails because it's like a big against the law thing. So anyhow, but I will have the answers to the questions and documents for you. All right. Hey, get things taken care of. Hang in there. We're getting closer and closer to being done. You guys are doing a great job. And I'll talk to you later.